All right, so start talking about absolute value. For the next couple days, I'll talk about absolute value equations. Introduce that today, talk a little bit about it briefly tomorrow. Then we're going to go to linear inequalities, which should be something that we can kind of breeze through because you've been doing them for a long time. And then get into absolute value inequalities. Okay? And talking about linear inequalities is just so we have the prerequisite skill to solve an absolute value inequality. Okay. First thing we got to know, what does absolute value of x mean? You guys remember what absolute value means?
Yep.
What?
How far away from zero it is.
Okay. So the distance x is away from 0. Okay? That can be to the right of 0 or to the left of 0, correct? Okay? So two different, let's say, positions. In that aspect right there, the fact that we can be to the left of 0 or to the right of 0 is the number one reason why we get two answers when we deal with absolute value equations. Okay? When we discuss absolute value, I'm going to, all the absolute values that we deal with right now, this will change as we move throughout the year and get some more procedures learned, but everything we talk about right now is going to be of the form ax plus b inside the absolute value bars. So that's a linear expression, right? Okay. If that is equal to c, that is going to generate then the equation ax plus b equals c, and then a second equation that says ax plus b is equal to the opposite of c. Okay? Now a picture of what we're talking about here would be this. If I start with 0 right there, okay, whatever I solve these for in regards to x, and I plug x in, that expression right there, ax plus b, can be to the right of 0 c units. Does that make sense? Or ax plus b, that expression, could be to the left of 0 c units. And that's why we get the c and the negative c idea inside our equations. Does that make sense to everybody? When we solve for x, we're not saying that x is that distance from 0. We're saying that when you plug x into the expression inside the absolute value bars, that distance is c units from 0. Okay? But we have to have those two ideas. The number one issue that I get with people is dealing with absolute value. There's always two components. And one of those components is always just to get rid of the absolute value bars and solve the remaining equation. That's all you've got to do for half the problem. Okay? Same thing happens when we talk about inequalities later on. But if I get rid of the absolute value bars, and I write 2x minus 5 equals 3, and I think that's the only thing that I have, and why even have the absolute value bars in the first place, right? Okay? So when you lose those, there has to be a give and take. I'm taking those away, but I'm going to add in then the idea that that expression could put me at negative c on the other side of 0. Does that make sense? So that first one might say we're going to put 2x minus 5, whatever x is, you're going to put 2x minus 5, 3 units from 0 to the right of 0. And that second one, 2x minus 5 equals negative 3, that value of x is going to put me 3 units to the left of 0. Okay? Now those are two linear equations that we can solve pretty easily, right? Okay? The one thing I didn't mention here is to apply this rule, okay? To apply this rule, I need to get my absolute value equation to look identical to it. Is there anything on this side with the absolute value bars? Is there like a plus D or anything like that, or no? So you need to isolate the absolute value bars. Okay, and that was already done for us in this problem. That's kind of why I overlooked it. Solve these. I get 2x equals 8, x equals 4, right? Here I get 2x equals 2, x equals 1. Now come back up here and check those. Plug 4 in there. What's 2 times 4 minus 5?
8 minus 5.
8 minus 5, which is 3, right?
Yeah.
What's the absolute value of 3?
3.
3. True statement, correct?
Yeah.
4 is a solution. Plug 1 in. What's 2 times 1?
2.
Minus 5?
Negative 3.
Negative 3. But it's in the absolute value bars, right?
Yeah?
Is negative 3, the absolute value of that, still 3?
Yeah.
Yes. So there is also a solution.
Wait,
Yes.
is this going to be in the homework that you just assigned you don't want to worry about?
Yeah.
Did you-
Well, yeah, we don't have any homework tonight, other than
Okay.
what's already been. What is that? 1-6. Finish that. That's all you got to worry about. Okay, so example 2. Example 2 is different, right? What do I have to do here first?
Subtract 5 from each
Oh,
side and then divide by 3.
Okay, so I'm going to have 3, absolute value of x minus 7 equals 9. Divide by 3. Okay, so at that stage, that mimics the rule that said the absolute value of a linear expression equal to c, then you get ax plus b equals c, or ax plus b equals the opposite of c, right? All right. Now, when we work through simplifying absolute value equations like this, or expressions on the left-hand side, your absolute value bars, you treat them like grouping symbols. You treat them like parentheses or brackets inside equations or expressions until you get to the point where you can actually apply the definition. Does that make sense? So all the lines of work that we did there, we subtract the 5, we divide by 3, that kind of stuff, that is, or those are procedures that kind of force us to use the absolute value bars like parentheses. Okay? But now that I've got it down to a point where there's no work that I can do inside the parentheses, obviously, now I can apply this rule. So now I have x minus 7 is equal to 3, or x minus 7 is equal to negative 3, right? So x is 10, or x is 4. Say again? In your homework, I'm going to ask you this. Type it in like this. Okay. What if I ask you this question? And we'll pick up with example 3 tomorrow. What if I said the absolute value of 3x plus 8 is equal to negative 24?
Impossible.
Why is that impossible?
The absolute value.
Okay, so when we read that, the distance that 3x plus 8 is from 0 is negative 24. You just said the distance of something is negative 24. The distance I drove to school today is negative 24 miles. That makes absolutely no sense, right? Okay? Distance has to be a positive number. So when they start you off with this, and what happens a lot of times, guys, is people are not paying attention. You'll do 5 or 6 of these absolute value equations, and basically you drop the absolute value bars, you leave what's there, okay, and then you take 3x plus 8 and set it equal to then the opposite of 24, or opposite of negative 24, and you just blindly approach it, okay? I refer to that as being kind of robotic. You just do the same steps over and over again. Well, if you do that here, you're going to get 2 numerical results, but neither of them make sense. Does that make sense, everybody? Okay? You always have to be thinking in the mathematics that we're doing. Maybe in the past, we could just kind of be robotic, and we really don't do a whole lot of thought other than your operations, like adding, subtracting, multiplying, dividing, and the arithmetic. Now we have to have the logic and the thought behind what we're really doing and what it's saying to us. Distance cannot be negative. They always provide you, so on Rhodes' final, they'll give you like 3 of these, okay? And the last one always has a negative C value to start with. Because they're trying to trick you, they're trying to get you to make that error. Okay? So be on the lookout for that. We'll finish up these examples tomorrow. Shouldn't take too long. We'll start linear inequalities tomorrow. Hopefully finish that too. That shouldn't take too long. And then that should allow you to do the one assignment that I've already added about that says linear inequalities. But don't address any of those today. Don't worry about it.